What is up? Daniel here with the Virtual Robotics Studio. We're back again with the XRP robot. This video, we are going to tackle teleoperated mode, so get your gamepads ready. But before we begin, special thanks to Argosy Foundation. All right, so once again, you're gonna need your XRP robot. Go ahead and turn it on. You can turn it on, I guess, when we get to downloading, but I'll just turn mine on right away. Get GamePad. We are going to assume you have either the Logitech GamePad or an Xbox controller, but I'll show you how to do it if you have a different controller as well. So go ahead and plug that into your computer. So that's ready to go. All right, and then let's get into the code. So on the computer, we are going to run, if you're not still in it, 2024 WPILib VS Code. And remember, if your program was the last thing you opened, it should open up to it. If you didn't, go ahead and hit File, Open Folder, and find that folder. So mine is right here. And the code is back. All right, and we are going back into robot.java. We don't need anything else. And our goal here is, as it finishes doing its opening checks, is to do our teleoperated mode. So in order to do that, we need to be able to use our gamepad or our controller. So the controller has a few different things on it that we can talk about. It's got the left stick, which has forward and backwards and left and right. So this is y-axis, and this is the x-axis on the left stick. We have the right stick, which is sort of the same, forward and backwards, left and right. And then we've got a bunch of buttons. So the buttons are labeled. Here we have the positional hat. I like using these buttons on the side as well, because a lot of times if you're driving the robot around, you're going to use these buttons without having to take your thumbs off the joysticks. Okay, but we have buttons which will be kind of Boolean. We talked about Boolean before. It means it's true or false, pressed or not pressed. And then the joysticks, the axes on the joysticks are going to give us a value between -1 and 1, which is great because that is the numbers that our motor wants. So essentially, we can just take the value from our gamepad, shove it into the motor, and everything should work. Almost. All right, let's jump in the code. First thing we have to do is import. So we need another import here. Maybe I'll add another // This is for teleop mode. All right, our import's getting kind of big. We are going to add another one, import. And it is edu.wpi.first.wpilibj. And the gamepad, as I said, is an Xbox controller. So we're going to choose Xbox controller. I think if you have a PlayStation one, you have PS4 controller is an option here. And if you have nothing that matches, you would just use joystick. And joystick, you'll have to go through and figure out what everything is specifically. So I'm going to use Xbox controller because in Xbox controller, I can say, hey, check button Y, and it's labeled button Y. And it just keeps everything nice and simple. PlayStation 4 will do the same, but if you're using joystick, it'll be like check button 3, and you're going to have to figure out what button 3 is. Okay, so .xbox controller. Now we have the ability to use Xbox controllers in our code. We need to scroll down to timed robot, where we do a new private final Xbox controller, because we have to actually set up the specific one that we're using. And I'm going to call this, I guess, M controller. Sure, M controller. For FRC, you probably will have a base or driver that controls driving the robot around, and another controller for if there's an arm or whatever else the extra appendages on the robot are. Usually that's split into 2 drivers. Here we're just going to do 1 driver for everything, so we'll just call it M controller. That is going to be equal to a new Xbox controller. And we need the open and close parentheses. This is asking for what port it's plugged into on the computer. We're just going to say 0 because we get to choose what port we plug it into. And make sure you get a semicolon there. All right, let's scroll all the way down. I think that's all we have to do until teleop. So let's go all the way down to teleop periodic. And remember, the periodic code is what runs in between these 2 curly braces. So I'm going to go in between the 2 curly braces and hit enter. And let's set up our drive code first. So we want to control our drive. If you remember in the last video, we created a drive object called mDrive, which takes both of the drive motors and lets us control them together. We're going to do dot, and let's do tank drive first. So we have tank drive. And this time, we're not going to put a number in here. So for autonomous mode, when we wanted to drive, we were like, OK, 0.6 and 0.6. That's drive forward at 60% speed. We're not going to do that here, though, because we don't want those numbers to be locked in. If we put a number there, we can never change speeds. Instead, what we want it to do is we want it to be controlled by where we put the gamepads, where we put the joysticks. So instead of giving it a specific number, we're going to say, hey, read the values from the joysticks, and that's what we want. So let's go tank drive. My tank drive got a little weird. Let me do the retype thing and see if that fixes it. Yeah, there we go. See, sometimes just retyping the exact same thing is all right. And we're going to put our controller, which is called mcontroller dot. And you can see when I do mcontroller dot, I can read all of the different buttons or axes on this thing. Everything is here. And the left motor, I'm going to control with the get left Y. So Y is up and down on the left joystick, which means the left joystick going forward and backwards is going to control the left wheel forward and backwards. Then what we'll do is the right joystick forward and backwards will control the right wheel forward and backwards. So to go forward, we'll push them both together. To go backwards, we'll go back on both. And then to turn, we can go forward on one and backwards on the other, just like we were controlling it on an autonomous mode. So we have get left Y, then we'll do a comma, and we will do mcontroller dot get right Y. There it is. And our code would be good, but there is one problem. And that problem is that gamepads were designed to work with video games. And in video games, the top left-hand corner of your screen is 0, 0, which means going down on the screen is actually positive. So that's the 0th line, then it's the first line, second line, and so on, counting down. So that means our joystick thinks when you pull it this way, we get positive numbers, and when we push it this way, we get negative numbers, which is opposite of what we want. Let's fix that in the code. So instead of just having the controllers here, if we just throw the little negative sign here, that flips the sign. So now instead of being like negative, or instead of being 1 when we go in a direction, it'll be -1. Right? So this is kind of like putting the negative symbol there is like saying times -1. So now we flipped both of them. This should work. And we're ready to test it. Let's go. Hit the button, simulate robot code. If your robot was not already on, and I just made the mistake, so we'll let this run. If your robot was not on and you're not already connected to it, when I turned my robot off, I went back to connected to the Wi-Fi here. So I need to choose to connect to the robot, and now I'm connected to the robot. So now I will simulate the robot code again. And this time we're going to choose teleoperated. Click on teleoperated. And the robot should be controllable now. What I want you to do, though, is the tendency is to just grab it and go crazy. We're going to go one at a time. If I push the left joystick forward, the left wheel should roll forward. Oh, we're getting nothing. OK, let's try again. Let's go back. And I think my code is all good. I might not have waited long enough to connect to the robot, so I'm just going to simulate again and see if that clears the problem up. Oh, I forgot something else too. So on this screen, this is probably what the problem was. Before we go to teleoperated, we have a list of here. This is things that the system reads in as joysticks. So you can see we have an Xbox controller here. But the joysticks over here, remember I said let's use joystick 0? That is this spot right here. So you have 0, and we could have up to 6 joysticks, 0 to 5. What we need to do is actually drag this Xbox controller. Left click on it and drag it where it says joystick 0. See how you get the yellow highlight? You can let go. Now that controller is connected to joystick 0. Now hit teleoperated mode. And now, once again, left joystick forward, I should see this wheel move forward. Yes. And if I pull backwards on the left joystick, that wheel should come backwards. Good. So now we verified that the left joystick is the left motor, is going forwards and backwards correctly. Let's do the same thing for the right side. Forwards, good. Backwards, good. Now if I do both of them forward together, we should drive forward. And you can see the more I push it, the faster it goes. So backwards, forwards, good. And let's turn by going forwards on one and backwards on the other. OK, that all feels right. The directions are good. So we're done. We have teleoperated driving mode. It was that simple. But there are a couple of other ways you can set it up. So that was what we call tank steering, where you use left joystick and right joystick for the left wheels and the right wheels. There's another way to control it, though, which is called arcade mode. And this is based more on what you would see if you were playing video games on console. Is typically the left joystick forward and backwards will control the whole robot forward and backwards. The right joystick then you kind of use to look around, but we don't have 3 dimensions on the robot, so the x-axis sideways would let us turn left and right. So let's switch our code over to use arcade mode instead. So remember, this is your reminder, close the simulation window. We can only ever have one of those open. And instead of tank drive, in fact, what I'm going to do is let's comment this out. So we have our tank drive line, cool. We'll save that. Now let's go ahead and make our arcade drive line. So mdrive.arcade drive. And this time what it wants is, so it wants x speed and z rotation. X speed and z rotation. And we could still square the inputs. So instead of giving it a left motor power and a right motor power, we give it a speed for forward and backwards, which is going to be negative mcontroller.get left y. No changes. Same thing, comma. The thing that is going to change, though, is our second thing is going to be the X stick on the right controller. So we're going to do mcontroller.get right X. Okay, make sure you get the, if you don't autocomplete, make sure you get the right capitals. And I don't think the X has to be flipped negative, but we're going to test it and find out if the robot turns the right way. So this is changing to arcade mode. I would say, let's go ahead and simulate it, and then I'll talk. So we got this running in the background. I would say that most teams these days are running on arcade mode instead of tank mode, just because the drivers are more comfortable with that. If your drivers are more comfortable with tank mode, do tank mode. More comfortable with arcade mode, do arcade mode. There isn't really a functional difference between the two. So if your driver is better at one than the other, use that one. All right, we don't have to move the joystick anymore. It's already in here. So let's go teleoperated. And let's see. So forward on the left stick, the whole robot should drive forward. Good. Backwards, it should all back up. Good. Sideways on the left stick should do nothing. Forward and backwards on the right stick should do nothing. But if I go sideways on the right stick, so if I go to the right, we should see the robot turn to the right. Oh, that's backwards. It turned to the left. All right, let's check left. It turns to the right. OK, so it's working. Controls are right, but our direction is flipped. So that means we got to go back to the code, close your simulation window. And turns out these both have to be negative. And that's how you troubleshoot that, too. Like, that's why I went through the process of let's test one action to one response and see if it's mapped correctty. Because then you can sort of work through, oh, that one's backwards, that one's not. So we have to flip this. So then we know in the code, we'll flip our mcontroller.getRightX to be negative. And we're going to simulate it. And we're going to see if that works. All right, and let's enable teleoperated mode. And so forward and backwards still good. Left now turns left. Right now turns right. So I should be able to, drive forward and turn at the same time. I gotta go slow because I don't want to fall off the table. Cool. So that is working the way that I would expect it to work. So try the 2 different modes, arcade and tank drive. Find the one that you like. And continue with that line of code for the rest of this program. I'm going to leave arcade in, but if you prefer tank, go ahead and uncomment tank, comment out arcade, and finish the code with that. All right, what's next? Next is let's control this servo. So we have the servo on the robot. We can move this servo to a variety of different positions. Let's use some of the buttons here to control which position it goes to. So maybe we'll have one position for this middle spot, one position for it tucked inside the robot, and one position for it folding out on the outside of the robot. OK, let's get to work. In our code, in teleop periodic, I'm going to make some spaces. So I have my drive up at the top, and now down here, we're going to start controlling our servo. And what we have to do is we have to check, right? There are 3 possible states for this. And when we need to check and make a decision, we're going to start with that if. And in this case, we're going to check to see if the controller button is pressed. So if mcontroller dot, and if I look on the GamePad, the A button is at the bottom. So let's say get A button. If we press the A button, let's say that's fold up inside the robot. And then X button is up a little bit, so that'll be move halfway out, and the Y button is the top button, so that'll be move all the way out. And if you remember, the buttons are Booleans. So get A button, this line of code right here, this whole section here that I'm highlighting, is either a true or a false. If it's true, then it's going to run the code inside here. If it's false, then it's not. You can also look at it like this. If you want to be very explicit, you could do equals equals true. So that means if the value of the button is true, then we run this code. Now you have to use double equals because a single equals is what you use to save a value into something. So double equals for comparison, single value to store a number or something in a variable. So this way is fine. You don't actually need the equals equals true though, because again, this is already true or false. But we'll leave it for this one and we'll do it different in the next one. Okay, so let's tab in. If you press this A button, we want to control our servo. Remember, it's called back servo. Always start with the name of the thing you want to control, dot. And for servos, we set position. And if you remember correctly from our autonomous mode videos, folded up is the number 1. So we're going to set it to position 1. Cool. Next step. If we want to move it to the next position, let's check another button. We can do else if mcontroller dot get. This time, we're going to look for the, like I said, X button. Get X button. And this time, I'm not going to do the equals equals true, because again, it's either true or false. If it's true, it'll run this code. If it's false, it won't. And in this case, we're going to do back servo, the name of the thing we want to control, to set position. And let's go halfway out, so 0.5. Remember, 0 and 1 are the extreme positions for the servo. So we'll go halfway in between. That's 0.5. All right. And you can see I did if and else if. And the reason why you want to do it this way is if you were pressing both buttons and I did another if like this, both of these code lines could run. And so the servo would be fighting between going to position 1 and position 0.5. So anytime you have an output, an actual right position, set motor speed, or set position, you want to make sure that only one line of it can ever run at the same time. And so what we're going to do is, with that else if, it can only run one. So if this is true, it ignores everything else. If this is not true, then it goes down and checks this one. If this is true, it runs it. If not, it can check the rest. So then we can have one more case here, and that is one more else if. And it's the same thing again, mcontroller.get Y button this time. And we're going to set the back servo to 1. So it's all the way up. And if you remember in auto mode, we did have that else case at the very bottom. We don't need an else case here because the servo remembers where it was and stays there. So if you press one button, it'll switch to that position. If you press the next button, it switches to that position. And it always holds the position in between. So we never need this sort of like catch-all reset case. So that, I think, is it. That should let us have servo control. So let's go ahead and hit our W and simulate the robot code. And let's go teleoperated. Our joystick is still there. Cool. And let's see. So if I hit the A button, the green button down here on the bottom, we should fold in. Perfect. If I hit the X button, it should go part way out. And the Y button should go all the way out. Oh, uh-oh. Somebody made a mistake. Let us close this window. What did I do? Position 1, position 0.5, and I did position 1 again, because in my head, 1 makes more sense for going out, but it is 0 to be all the way out. All right, so we'll make that change. Re-simulate the robot code, and let's test it. All right, teleoperated, looks good. Okay, A, close all the way, X, move halfway out, and Y, move all the way out. There we go. So we now have control of that servo, and we can be driving the robot around at the same time. And those things, like I can be moving forward and moving the servo simultaneously. They will run. It runs both lines of code, so we can be checking all of this stuff at the same time. So that is pretty functional. There's one more thing that we're going to try to add to this robot in Teleop. You could be done now, actually. That's basically, you have complete control of the robot. But there's one more thing that we see a lot, and that is this robot, it's pretty quick. If you had to line it up perfectly, like if I had to drive over and line it up perfectly on something, on my mouse or something like that, it's not super easy when it's full speed. The turning back and forth jumps pretty fast. And yes, you can use the joystick and try to just nudge it into position. But sometimes, especially on the FRC robot, what can happen is it's hard to get enough fine control at the low end. So squaring the inputs sometimes can help with that. You can experiment with that. But there's another thing we can do. We can use some more buttons on the GamePad. And partly we're doing this just so you get more coding practice. We can make one button, make it so that our maximum speed is like 70%. And then if we hit a different button, we go back up to 100% speed. So we can use that to sort of limit our speed when we're doing fine adjustments or driving through an area where we have to be careful. But then we can hit the other button and take off at full speed if we have to drive a long distance. So let's do that. Let's take a look at our code here. Close the simulation window. Now we have to do one thing really quickly. In order to do this, we have to remember whether we're in high speed mode or slow speed mode. So what we need to do is go all the way to the top of the code. And we are looking for, let's go to where we did our public class robot extends timed robot, where all the private final stuff is. And I'm going to go down here to the bottom. And I'm going to do a, so this variable controls the max speed of the robot. OK. And we need to create a variable. So variable is, if you've done it in math, same thing. Variable is just a word that is going to represent a number. And that number could change based on us doing different things. But anytime we want to know, should we be in full speed mode or half speed mode, we want to be able to say, hey, look at that variable. Whatever that variable says is the answer. So we can name it whatever we want. I'm going to call it, let's call it drive speed. This is our speed limiter of the robot, I guess. And we'll say that is equal to 1. So when we start the robot, we're going to have full speed. Now, we have to do one more thing on this line of code, which is that drive speed, we need to tell it what kind of number it is. And we talked about Booleans. Boolean is true or false. You can have a Boolean variable that's either true or false. We can have an int variable or an integer variable. That means you can only use whole numbers. But we need a ratio here because we want to either be driving at full speed or maybe 70% speed or 60% speed. That means we have to use decimals. And if you're using decimals, then the type of variable you need is a double. So we're going to type double here. OK, so double drive speed equals 1. All right, now we're going to use that. Scroll all the way back down to Teleop periodic. And find the line of code that you're using. I mean, I guess we can hit enter, and both lines of code will be inside of it. Actually, they'll both be below it. OK, hold on. So here's what we're going to do. Our drive speed right now is 1, that variable. So if I went in here and did times drive speed, this line of code is now the controller value, negative the controller value, times the number 1. Well, anything times 1 is just the number, so this makes no changes. But if drive speed was 0.7 or 0.6 instead, actually let's say 0.5 because then it's easier to think about. If we made it 0.5, then the value from our GamePad gets flipped, gets made negative, and then multiplied by 0.5 is the same as dividing by 2. So we're cutting it in half. That means you have half speed. So let's do that not only for the left stick here, but also for the right stick. Let me get rid of this so we can see the whole line. So then we're going to do times drive speed here as well. OK. OK, so this line cuts off just a little bit. But no, you need the close parentheses and the semicolon there and drive speed. All right? And that's the idea. So now, if drive speed is left at 1, I'll get rid of some spaces and it'll fit better. If drive speed is 1, then we make no change. We have full speed that we can use on the robot. But if we hit a button, we can make drive speed drop down to some lower speed. So let's do that part of the code now. Now this part of the code you want to put above this part of the code. We want to read in what our speed change is before we set the speed to the drive. So I'm going to go basically above it and say if, and all we're doing is we're going to read in from a button. We already know how to do that. We did that 3 times down below. So mcontroller.get, and I'm going to use the bumpers. So the top buttons on the sides, here and here. This is right bumper and left bumper. So in my mind, right bumper should be faster. So I'm going to do get right bumper. And this means if you're pressing the right bumper, then we're going to make our drive speed variable equal 1. That's full speed. And get a semicolon there. Next, we can do an else if. And open your parentheses. mcontroller.get left bumper, right? We'll read the other side. And if the other side button is pressed, then we're going to reduce our speed. So we do that by saying drive speed equals, I'm going to do 0.6. 0.5 I think might slow it down a little bit too much, but 0.6 was driving well in auto mode. So let's do 0.6. So now, if we press the left bumper, drive speed goes to 0.6, which means this line of code, we are multiplying by 0.6. So whatever this number was from our left Y when we were driving, it's now 60% of that. We multiply it by 0.6. And same thing for our turning value. All right, I think that's it. Let's test it. W, simulate robot code. And we're going to enable teleoperated mode here. And let's see, on the robot. OK, so it should be full speed. Let me put it here. So I'm going, this is full speed. I'm going to hit the button. Now it should be going slower. That is now full speed. Joysticks all the way. But you can see that is definitely slower, right? And I can go, and if I hit the other button, accelerates up or slows down. Oh, I got stuck. Same thing. Let's test it with turning. So turning is very fast. If I hit the button, we're slowing down. If I hit the other button, back up to full speed turning. So now you could drive like far distances fast, but then when you get close, you could hit that button and have slightly more control on your turning to line up, nicely for where you want to be. All right, that is actually it. We have completed our teleoperated code. So you now can control with the GamePad. You know how to use the buttons. You know how to control extra functions on the robot with the servo. If there was a different motor, you could do everything the same way, except with motors, instead of telling the servo to go to a position, we tell the motor how fast to spin. So all of that should be something that you can do now. Map buttons to functions on the robot and use the gamepads to drive it in either tank mode or arcade mode. All right, so that's all we've got for the XRP. We recommend that you continue to play with it, make some changes, challenge yourself, come up with something else that you want to try to make the robot do, and work on that. And when you get started with FRC in January, if there's some things your main robot, your FRC robot is going to do, try to make those things work on the XRP robot. Your programmers can get the XRP robot out. They can start programming right away, day one, as soon as you have some ideas, while the rest of the team is still working on building, wiring, and setting up the main, big robot. So that is where it is very powerful. All right, that is a job well done with the XRP robot. You've made it through all of the programming we have for you on that one. We will be back, though, in season with build videos for the KitBot, the robot that first is putting mostly in the kit parts. You might have to pick up some extra pieces. But once again, before we go, we want to give a special thanks to 302 Lake Orion High School for hosting us here, so we have a place to film. And as always, to Argosy Foundation for making these videos possible.